Hello everyone, I'm sorry I couldn't be here. I am having to tend to something, so I had to throw this together a little bit last second. I wanted to be here to kind of work through this investigation, but we'll have to make do with what we have. To start, you can hold on to yesterday's homework. We'll go over that when I'm hopefully back tomorrow. And then as far as today's, actually, if you would to start, there should be a box up on one of my second desks. If you come up and open it, there's some Ziploc containers full of what are called algebra tiles. They should look like this. They're Ziploc containers that have a variety of pieces. They come in 3 different sizes. They come in big squares, they come in kind of rectangles, and they come in little squares. There should be a variety of pieces. So if everyone could come up and first grab a pouch to start. So pause the video now, have everyone come up and grab a pouch to start. And then once everyone has it, then you can push play again. Okay, to start today though, what I first want to actually do is do a warm-up. So first question involves what we were doing yesterday. We were looking at how do I add polynomials. So the first question is how do I add polynomial 1, which I'm going to underline here in red, and then polynomial, the second one, how do I add those two things? And what we're looking to do is add like terms. And then the second one is hopefully a simple question, but I want to see what type of creative answers people come up with. Can you make a visual diagram to show what 2 times 3 equals? We all know it's 6, but could you show a visual diagram to help someone understand why 2 times 3 would equal 6? Those are our 2 warm-up questions. The first one is what we did yesterday. The second one connects to kind of what we're doing today. So pause the video now, give everyone maybe a minute to try this, and then come back after everyone's had a chance to try it. A good place to be to put it on somewhere on the homework from yesterday. Okay, welcome back. Let's go over the first one. The first one, I'm going to add these 2 polynomials. The way I'm going to do it, I'm going to use a vertical method to add these. So I got 7x squared plus, I don't have any x's, so I'm going to actually put 0 x's for this red one. Then I have 2 1s. So I have my x squared column, my x column, and my 1s column. Now I'm going to add these guys. So I have 1x squared. There's actually a 1 out in front of this, so I'm going to put 1x squared. How many x's? I have 2 x's positive, because there's a plus, and I have minus 12 1s. Now I've lined them up. I'm really just adding my like terms. I'm counting how many x squareds, how many x's, and how many number 1s I have. In total I have 8x squareds, 0x plus positive 2x, I have positive 2 x's in total, and positive 2 plus negative 12 is minus 10 1s in total. When I add those 2 polynomials, that is what I get. Second one, I wish I was here to see what type of creative ideas you guys came up with, but I was hoping maybe, and if not, it's okay, maybe somebody thought to do something like this. To explain why 2 times 3 is equal to 6, did anyone maybe think of it like in terms of area? If I had maybe 2 tiles on this side, so this was a length 2 on this side, and this width was 3 wide, I would say the area of that rectangle is 2 times 3. You know, if I had a rectangle that was 2 maybe feet on this side and 3 feet on this side, you guys would tell me it's, well, the area is length times width, 6 square feet. And we're actually going to use this type of idea and those algebra tiles and those Ziploc bags to help us understand how we can not add polynomials. We added polynomials yesterday. We're going to start to move forward and do multiplying them. So how can I start to multiply polynomials? We're going to start pretty easy though, with some things that are a little familiar, and then get a little bit more abstract. To start then, there's no note packet today. This is all, I would highly recommend taking notes as we go through it. It'll help you with the homework. And then we're going to be using those algebra tiles in those Ziploc bags. I ask you to be responsible for them. It's very important that all the pieces that started in your bag end up back in your bag, because I'll be using these in the future. Okay? So moving forward, could you make a visual diagram showing what 2 times 4 is, and maybe consider using those little yellow squares that are in your algebra tiles? Can you, for me, show what 2 times 4 would be using algebra tiles? So pause. Actually, no, we'll do this one. I'll let you try the next one. So what I'm saying here is, can I make one to show 2 times 4? Well, it would be 2 this way And then if it was 4 wide up here, what I'm eventually going to notice is if it's 2 in length and 4 in width, well, how many would end up being down here? What I would see is, okay, I'll just copy and paste for sake of time. There'd be one row of right there, and if I get another one, I'm going to see in total there's 8. 1, 2, 3, 4, 5, 6, 7, 8. A 2 times 4 gives me an 8. So that's how I can use it even in the simple case of showing what 2 times 4 is. So if you want to, you can try and lay it out using your algebra tiles as well, even with these simple cases. What about something like 2, and not now times a number, but like x plus 3. So what I'm imagining here is this. This is where it's going to start to push your thinking a little bit. So this 2 maybe tells me how tall this is going to be. And what I have in this toolbox of algebra tiles, if you notice, there are 3 different shapes. One of them are yellow. One sides are all reds. Those are used to denote negatives. We'll use those a little bit later. But right now we're going to consider the blue, green, and yellow pieces. The yellow pieces are area 1 because they're length 1 by 1, we're going to say. The green pieces, they're area x. And the reason that they're area x is because they have the same width as the 1. They're 1 wide, and their length is x. And 1 times x is x. The blue guys, they're square, and their length is x by x on each side. And you'll see that they line up the same as the green ones in their length. It's x by x, so its area is x squared. And we're going to use that to help us visualize what about 2 times x plus 3. We know from back before we would use distribution. I want to show you how you can use this new idea of area, and it'll help us when we get more complicated. So right now I have 2. I have a length 2. If it's a length 2, that means length 2 is a 1 and a 1. So there's a 1 here and a 1 here. How long is this side? Well, it's 1 and a 1. So that is 2. Now I need a side that's length x plus 3. Well, in order to be length x, I need to grab one of these green tiles. So I'm grabbing one of these green tiles. This is like framing your structure. If you think about it like carpentry or construction, this is like framing the foundation before we pour the concrete or something like that. There's length x. I know this is length x right here. Now I need length 3. So I need a 1, a 2, and a 3 to kind of go in here. So I need to grab 3 of these yellows. So 1, 2, and 3. Now I've kind of laid out my foundation. Are my dimensions what they need to be? Yeah. One side is 2, the other side is x plus 3, so I have 2 times x plus 3. What's my area going to be? Well, my area is going to be, if I multiply 1 times x, I'm going to get x here. If I multiply another 1 times x, when I fill it in, the only piece that's going to fit here is another x. Now this is a 1 by 1. The only thing that would fit here in my foundation would be like another yellow. And I kind of continue filling in with these yellows. So I've used 2 times x plus 3 to kind of be the dimensions of my rectangle, and then my answer, the product, is actually what are all the pieces inside. If I look at the pieces inside, what's left inside? Well, I have an x piece, an x piece, 1, 1, 1, 1, 1, 1. Hey, I have 2 x's plus 6 1s, and that's the exact same thing I would have got if I'd actually just distributed. If I just distributed, I would have got 2x plus 6. But instead, I use these algebra tiles to help me visualize kind of what's going on. So now I want you to try that same idea. This 2 told me this dimension on this side. X plus 3 told me the dimension on the other side. You try it with 2 times x plus 1. Can you lay out the length and the width for that? And then give it maybe 2 minutes. Try laying it out on your desk. Compare with your neighbor, see if it's the same answer you would have got if you had done distribution. So you need something that's length 2, and then something that's length x plus 1 on the other side. And then I want to know what's going to be the area underneath. So pause the video now, come back after 2 minutes, and everyone's had a chance to try. Okay, welcome back. So first thing, I need a length 2 on this side, so 1 and 1. Now this whole side is 2. And I need something that's x plus 1, so I need an x. And I need a 1 here. Hey, now it's x plus 1. I can erase this little extra piece I don't need. And what's going to be, so there's my dimension right here. Now what's going to be my area? Well, the only thing that's going to fit inside to fill it in is I need a green here, and then 1 by 1 is going to be a 1, and a 1. Hey, inside I get the exact same thing. I get an x, I get an x, I get a 1, I get a 1, as if I had distributed. If I had distributed, I would have got 2x plus 2. So hopefully right now you're thinking, oh, this is kind of interesting. I can use area to think about multiplication, but it's really not useful. I already knew how to do this distribution before, but where it does become useful is when I have two polynomials, and that's where we're going to move into now. Before I wanted to do that, I wanted to show you how to think about it with a negative. So if I had a 2 times an x minus 2, how do I think about negatives? Well, the way that they do it with algebra tiles, if you flip any of your algebra tiles over, you notice that every single one has a red side, and the red side denotes negative. So I'll show you how that works to visualize it. So I'm going to draw my little foundation, something like that maybe. I need one side that's length 2 and it's positive, so I'll use my positive yellow. So now it's length 2 on that side. Its width is x, so that's a positive x. Now it's a minus 2 though. Since it's minus 2, I'm going to use the red side. So I have one red. I'm going to copy and paste that. And I need another red. There. Now this side, I'll show you. So this is a length 1 and 1. So this side's length 2. Right here, this is 2. This side is length x, and then it's a negative 1 and a negative 1. And I understand it's kind of cheating to think about negative distance. But we're going to use it by using colors, so that's how we're going to denote that. Now if I think about what would it fill in with, here's a positive x and a positive 1, so there'd be an x down here, and then another x down here. Now I need to be a little smart. A negative 1 times a positive 1 means when I multiply a negative and a positive, the only thing that could go down here would actually be a negative. So I'm going to multiply through, I'd fill in negatives down here. And the reason why is because one of my dimensions was negative. So when I multiply 2 times x minus 2, what are the area pieces I get down below? Well, I get an x, I get an x, I get a negative 1, I get a negative 1, I get a negative 1, I get a negative 1. In total, I have 2 x's, and I have negative 4 1s. And hey, that's the same thing I would have got if I had distributed. I would have got 2x minus 4. Yeah? Now I want to show you where it becomes useful when I'm multiplying two polynomials. We're going to skip this 3 times x minus 1. I want to look at this. So for example, what if I have x plus 2 times x plus 3? This is where we're going to have to start to get clever. So on one side of my foundation, I need a length x plus 2. On my other side, I need length x plus 3. So I'm going to grab one of these. It's length x plus 2, so I need to kind of turn this guy in order for its length to be x. So there's length x. Now I need 2 1s on this side, so 1, 2. Now let's look at this. Is that really x plus 2? Its length here is x, 1, and 1. If I asked you how long it was, you'd say it's x, 1, and 1 makes 2. So yeah, it's length x plus 2. On the other side, I need length x plus 3. So x and then 1, 2, 3. And is that length x plus 3? It sure is. Length x, 1, 1, and 1, x plus 3. Now I need to fill this in, and we're going to finally get our blue piece. We haven't found one before, and we're going to get it now because this in the upper left is length x by x, and the only thing that's going to fill in there would be a blue piece, because the blue piece is the only one that's x by x. Now this is 1 by x, so I need some green pieces. Those are the only things that are length 1 by x. They're just going to be vertical. That's okay. It's the same area. Got it. Now here, the only thing that's going to fit down here is that piece that's x wide and 1 tall, and that's these guys. Grab these guys. And then down here, all of these are 1 by 1s, and those are yellow pieces. So I'm going to grab 1, 2, 3 yellow pieces, and then I need another line of them, so I'll just copy and paste them. Hopefully you're following along making these as well with me. What we see then, when we multiply x plus 2 times x plus 3, what do we get in total? Well, we get an x times an x, we get an x squared, which hopefully isn't too surprising. We get 1, 2, 3, 4, 5 x's. And then how many 1's do we get? 1, 2, 3, 4, 5, 6. That's kind of interesting. So in total I get x squared plus 1, 2, 3, 4, 5 x's and 6 1's. So I would say x plus 2 times x plus 3. What does it give me? What does it equal? It equals this. This is going to be my area. And you might start to notice some patterns. Why did we get 6? What's the relationship between 2 and 3 that gave me 6? What's the relationship between 2 and 3 that gave me 5 x's? Maybe you'll start to recognize those patterns as we do a few more. So moving forward, what about if I did 2x plus 2 times 2x minus 3? So again, grab your tiles out, erase the one you had before. On this side we need length 2x plus 2. This is going to be kind of a big one. And then on this side, I need 2x minus 3. So I'm going to grab my green tiles because I need 2 x's. So 2x, turn this a little bit more, there we go. I need another one. There's 2 x's and I need 2 yellows to get my dimension on this side. Now over here I need 2 x's, and then how many 1's? I need 3 of them, but they shouldn't be yellow, they're going to be red because they're negative. So a negative, a negative, and a negative. And now I've laid out my dimensions. One of them is 2x plus 2, the other one is 2x minus 3. Now I need to fill it in to get my area. Up here I have an x by an x, so there's going to be one blue. Then I have another x by x, there's going to be another blue. Get another x by x, there's going to be another blue here. And one more blue. So I get 4 blues. You might see the connection because it's kind of like 2x times 2x. That gives me, well, how many x squareds? Gives me x squared, x squared, x squared. I get 4x squareds. Now what's going to happen is I get -1 times x. So there's going to be some vertical green ones here, but they're not going to be positive, and the reason why is because these are negative. So I need to grab these guys. I'm going to put them over here, but they're going to be negative, and the reason why is because one of my dimensions is negative. So I'll grab him, put these here. So I get 1, 2, 3, and actually there are going to be 3 more right down here because again I got -1 wide, x tall. So grab those. So in total I'm going to need 6 vertical reds right here. And then down here I have x wide, 1 tall. Those will be positives. So I can grab some greens, fill those in. Okay, 2 more. 2 more. And then the last ones is I have -1 and +1. That means all of these ones down here are going to be red, negative. And that's because they were negative wide. And a negative times a positive is going to make it negative. Now I need to count up all of my pieces. And there's going to be some negatives and positives floating around. That's why we practiced this yesterday. So in total, I have x squared, x squared, x squared. I have negative x, negative x, negative x, negative x, negative x, negative x. These are all positive x's. Down here I have -1, -1, -1, -1, -1, -1. Now I just need to report how many of each I have. How many x squareds do I have in total? I have 4 of them. So when I multiply these two things right here, 2x plus 2 times 2x minus 3, I'm going to get, I need to slide this down a little bit. So when I multiply 2x plus 2 times 2x minus 3, what do I get? I found I got 4x squareds. Here's the tricky part. I have -6 x's plus 4 x's. So negative 6 and plus 4 mean in total there's going to be negative 2x's. And the reason why is 4 of these positives are going to cancel 4 of those negatives, leaving negative 2x's left. So you can imagine this cancels with that, this cancels with that, this cancels with that. Positive x and a negative x make 0. What's left? Those two. And then in total, what also is left? I have negative 6 1. So I'd say negative 6, and I'm done. That is my area. You can kind of see this takes a long time, so you can also use what's known as a table or a generic rectangle method. And what you do is you list out your dimensions like this. It's just a little quicker. You don't need to use all the shapes. You can say, okay, one of my dimensions was 2x. This one was positive 2. This was 2x, and this was minus 3. What did I get in total? 2x times 2x was 4x squared. 2x times a negative 3 is negative 6x's. 2 times 2x would be 4x's. Those are my green ones. And then 2 times negative 3 is negative 6. So in total, hey, there's my 4 blue x squareds. Here is going to be negative 6x and 4x in total. These will say how many are there in total for x's? Well, there's negative 2x's in total. And then here are my negative 6 ones. So in total I have 4x squareds minus 2x minus 6. So you can also use this generic rectangle, or I like to call it the table method. To close out, final one is I want you to try to make one that's x plus 3 by x plus 3. So pause the video now for maybe 2 minutes. Make a shape that is x plus 3 by x plus 3 and tell me what the area is inside. Okay, welcome back. Hopefully everyone had a chance to try it. If you didn't, pause it now, give everyone a chance to try. So I want something that's x plus 3. So I'm going to take this, turn it, so it's x, and then I need 3, positive 1. So 1, 2, 3. And then I also need this exact same thing going the other way. See if it'll let me do it. So I'm just going to turn it. It's going to be x plus 3 going the other way. And what do I end up with in total in there? Well, I'm going to see I have an x plus, or x by x, that's an x squared. Now I'm going to get 1, 2, 3 vertical x's, and 1, 2, 3 horizontal. That's okay. In total, I would say there's 6 x's. And then I'm not going to put them down here, but you can imagine how many yellow ones am I going to have down here? I'm going to have 9 of them. I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So in total, I would say I have 1x squared. So this equals x squared. 1, 2, 3, 4, 5, 6 x's, so plus 6 x's, and 9 ones. That's the area, and that's my product when I multiply those two things. If I used a rectangle method, it would be x plus 3 by x plus 3. This is x squared. X times 3 is 3x. 3 times x is still 3x, and 3 times 3 is 9. In total, I have an x squared. I have 6 x's, and I have 9 ones. Yeah? Your turn to try on the homework. Our sub should pass out a little sheet for you. I'm going to do the first one right now so you can follow along. So pause the video now. Once everyone has it, then they can follow along, and this will show you what I kind of expect. So pause the video now. Make sure everyone has a copy. Okay, once everyone has a copy, for example, this first one says, I want you to use the area model with algebra tiles to show me x plus 2 by x plus 3. So here that means this is going to be something like x and then plus 2. So there's my first dimension. Now I have x and then 1, 2, 3. So what's this going to be? This is an x by x. This is going to be my x squared, my blue x squared. Here's a vertical piece. Here's another vertical piece. How many vertical green pieces would I have in total? I have an x, an x, an x, an x, an x, and then I would have had 1, 2, 3, 4, 5, 6 ones. 3, 4, 5, 6. So in total, I would say my area is x squared, and then 5x, and then plus 6. Kind of hard to see, so I'm going to go back over those yellow. Plus 6. That would be my area. I would have had a blue square, x squared, 5 rectangle, x pieces, and 6 square 1 pieces. So x squared plus 5x plus 6. If I didn't want to draw the shapes out, I could have just done x plus 2 and x plus 3 and said the area was x squared, 3x, 2x, and 2 by 3 is 6. In total, I would have said there was an x squared. There are 5 x's, and there are 6 ones. Same exact thing. Your job to fill out the final 5. We'll take another day at this tomorrow. We'll practice a little bit with algebra tiles and then mostly move towards a new faster technique called foiling and checking our foil with the table method as well. So tying it all together. So your turn to give it a chance with the 5 questions left on the worksheet, and then hopefully I will be seeing you tomorrow. Thank you.